Now let's talk about Pauling's electronegativity. So the electronegativity periodic table, which we saw earlier, that is actually based on Pauling's electronegativity. So it originates from the concept of valence bond theory, VBT. In a covalent bond AB, the ionic forms also contribute. The contribution depends on the electronegativity difference between A and B. So these two atoms, which are forming a covalent bond, so inside their covalent bond, they also have some ionic nature. Now, because of the covalent ionic resonance, the actual bond energy is always greater than the hypothetical 100% covalent bond. So as I mentioned, if there is a bond between two atoms A and B, so the bond is having some portion of covalent bond and some portion of ionic bond. So that is called covalent ionic resonance. So some part is coming from the covalent bond, some part is coming from the ionic contribution. So that's why, because of this ionic resonance, because of the presence of this ionic nature, the actual bond energy, which is EAB, that is always greater than the hypothetical 100% covalent bond. So this difference gives the measure of covalent ionic resonance energy. So what happens? The actual bond, which is having higher strength, if you take that and then subtract the hypothetical 100% covalent bond between A and B, the amount whatever you will get, that represents the covalent ionic resonance energy. So how you can write? You can write this covalent ionic resonance energy delta is equal to actual bond energy minus energy of the corresponding 100% covalent bond. So this delta AB represents this covalent ionic resonance energy. That is actually EAB, the actual energy, minus EAB covalent, which represents 100% covalent bond. So this EAB covalent can be written as this geometric mean. So this is the geometric mean of these two. To understand this, first we have this molecule A2 and we have this molecule B2. Okay. Now, if you break these two bonds, and if you break this bond, and if you break this bond, and then if you join this A and B, so this energy of this AB will be actually equals to this value, square root of energy of AA multiplied by energy of BB. Okay. So we can write this value in term of this energy of 100% covalent bond between AB. So if you put that, we get delta AB is equals to EAB minus under root of EAA into EBB. Now Pauling suggested this 100% ionic character in AB bond is actually proportional to the difference between their electronegativity, that is proportional to chi A minus chi B, and that is also proportional to square root of covalent ionic resonance energy, or delta AB. So from here we get that chi A minus chi B. This chi is the symbol of electronegativity. So electronegativity of atom A minus electronegativity of atom B is actually square root of delta AB. That means if we take the square root of this covalent ionic resonance energy, we get the electronegativity difference between those two atoms. Now this chi A minus chi B, whichever is greater, you can take that. If electronegativity of B is greater, you can take chi B minus chi A. Okay. So if we put the value of this delta, which is this value, we get chi A minus chi B is equals to this equation. So here delta is in eV, electron volt per molecule. So from there, we observe that chi A minus chi B is proportional to under root covalent ionic resonance energy of delta AB. Okay. So chi A minus chi B is equal to under root delta AB. And here delta was in eV per molecule. Now 1 eV per molecule is equals to 96.5 kilojoule per mole. So we can convert this value from eV per molecule to kilojoule per mole. We just divide it by 96.5 and eventually we will get 0.102 square root of delta AB. So here this delta value is in kilojoule per mole. So this delta is the covalent ionic resonance energy. And from there, if we take this value in the left hand side and we square it, then we get delta AB is equals to 96.5 into chi A minus chi B whole square. So this is the one equation that you have to remember, this one. And also this one, chi A minus chi B is equals to 0.102 square root of delta. Here delta is in kilojoule. And also you have to remember this one, here delta in eV per molecule. Simply if you just put 0.102 before this term, you will get delta in kilojoule per mole. And similarly, you can convert this eV per molecule to kilocalorie per mole using this factor. So if you just divide it by 23.06, you will get chi A minus chi B is equals to 0.208 square root of delta. So here delta is in kilocalorie per mole. So these three things, these three formulas you can remember, And from here, if we just take this factor in the left hand side and then square both the sides, we will get delta AB is equals to 23.06 chi A minus chi B whole square. So these formulas you have to remember, and I will erase all these things. You can take a screenshot of this. You can pause the video and take a screenshot. Now we will discuss about different type of electronegativity. Earlier we observed Pauling's electronegativity. Now we will discuss about Mulliken's orbital electronegativity, which is represented as chi m. Now Mulliken said that electronegativity of an atom is orbital dependent, and electronegativity of an atom is related to both ionization energy and electron affinity. So Mulliken suggested that chi m of atom A is equals to half of the summation of IEA, means ionization energy of A, and electron affinity of A. So this is in eV per atom. So you can again convert this eV per atom to kilojoule per mole. You have to just divide it by the factor 96.5, and you will get chi m, or the Mulliken's orbital electronegativity, is equals to 0.0052 IE ionization energy of A plus electron affinity of A. So here this ionization energy and electron affinity, those are in kilojoule per mole. Similarly, you can convert this formula in kilocalorie per mole by dividing by this factor 23.06. If you divide it, you will get chi m is equals to 0.0217 ionization energy of A plus electron affinity of A. So here ionization energy and electron affinity, they are in kilocalorie per mole unit. Again, I will remove all those things. You can pause the video and take a screenshot. Now let's see the relation between Pauling's electronegativity and Mulliken's electronegativity. So the relation is given as chi p, means the Pauling's electronegativity is equals to 0.168 times of this ionization energy plus electron affinity of the atom and minus 1.23. So if we subtract this 1.23 from this ionization energy and electron affinity value, and then if we multiply it with 0.168, we get Pauling's electronegativity. Now this can be converted into Mulliken's electronegativity. This IE plus EA, and we know half of IE plus EA is equals to chi m. So you can just convert it to chi m, and ultimately we will get 0.336 chi m minus 0.616, which will give 0.336 chi m minus 0.2. So this is the relation between Pauling's electronegativity and Mulliken's electronegativity. And even some scientists proposed that chi p and chi m should be related like this. Chi p is equals to 1.35 times of square root of chi m, and then you subtract the value 1.37. So any of the values, both the formulas you can use to relate the Pauling's electronegativity with Mulliken's electronegativity.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.